Hello everyone, this is the Hesi A² chemistry review. If you found this video helpful, be sure to like this video, comment down below and come back and let us know when you passed, and share this video with a classmate who you know may be taking a pre-nursing exam soon. Now on the Hesi, you can expect to have between 25 to 30 questions. And out of those questions, I believe 25 of those questions will be actually graded or counted toward your overall score. Now you'll be given about 25 to 30 minutes depending on your institution. So let's get started with some definitions, okay? So first we have chemistry. Chemistry is defined as a study of properties of matter and the changes that matter undergoes. Now what is matter? Matter is anything that takes up space and has a mass. What is mass? Mass is a measurement of matter that an object contains. It's not like weight, okay, but it's mass. It's a measurement. Now, substance is matter that has a definite or constant composition and distance priorities. Mixtures. We'll talk more about mixtures in a little bit. Mixtures is a combination of two or more substances in which the substances retain their distance identities. Compound. A compound is a substance composed of two or more elements. So what is an element? An element is a substance that cannot be separated into simpler substances by chemical means. So here's pretty much a visual of a classification of matter, pretty much what we just discussed in the last slide. The structure of an atom. An atom is composed of three different components: protons, neutrons, and electrons. Electrons have a negative charge and they are located on the outermost shell of the atom, and the protons and neutrons are located inside of the atom's nucleus. The protons are positively charged and the neutrons have no charge. If you're taking your Hesi pre-nursing exam, you may want to download this checklist. It contains all subjects we discussed on this channel. You can check off certain subjects and concepts that you felt that you've mastered and certain ones that you need to work on. I recommend having at least 1 month before your testing date to study. 100 hours a month, 3 hours a day, or 21 hours a week. To purchase this checklist, check the description box below. Homogeneous and heterogeneous mixtures. Hetero means different. Homo means the same. Now, the hormone mixture is a uniform mixture. This can be like making tea, making matcha, making coffee. When you stir all these ingredients up together, it's uniformed. There's no distinction between where's the sugar molecule. You can't see it. It's uniformed. Now, we have a heterogeneous mixture. These are mixtures that you can actually see the difference. You can see the different substances. So pizza, that's an example. You see the spinach on pizza, you see the onion, you see the pepperoni. It's not uniform. So it's important to know the difference between a solvent, solute, and a solution. Now, a solvent is doing the dissolving. It is dissolving the solute. And your solute is something that's being added to the solvent to be dissolved. Now, when you have your solute and your solvent together, they make collectively the solution. Now, typically it is water, but it also can be in other forms like an oil or whatever. But in this case, our scenario, we have salt water. Well, water would be our dissolving agent, and the solute in this case would be salt, and together they collectively make up a solution. So on the Hesi, you need to know basic information about the periodic table. Now, you don't have to know everything about the periodic table, but just the basics, like the group names, where are the metals, where are the non-metals, where are the periods, do you know how to differentiate where are the groups? So just stuff like that, okay? So the groups are arranged up and down vertically, and the periods are left to right, okay? Left to right. Now, the heavy metals are at the bottom and the lighter ones are usually located at the top. That's how they arranged it. It's literally so organized, okay? It's very organized. So the group numbers on the top of a periodic table shows you how many electrons are in a shell. Now, this is a basic picture that you see now, but I'm going to show you guys a picture of a more complex periodic table. Now, you may notice that each element on the periodic table has numbers surrounding it. Now, the numbers inside of the element tells the story, or it tells you more information about this particular element. Now, the number at the top is the atomic number. This is the number of protons that sulfur contains. And then we have the atomic mass. This is the number of the protons and neutrons that sulfur contains. We have the element symbol. We have the element name as well. You may see periodic tables that don't always have the element name, but it's not really a big deal. Now, you may notice, and what I did remember seeing on the test, that the atomic mass and atomic number will switch. Now, don't let big numbers fool you. I remember seeing something like an X, and I remember it having 200 and something, 256 as a mass, and 14 or 17, something like that, as an atomic number, but the atomic number was written at the bottom and the atomic mass was written at the top. So your atomic mass would always contain more because it contains the protons and the neutrons, and then the atomic number is just the protons. So with that being said, we're going to do some practice problems on how you can find your neutrons in a particular element. You will run across questions on the test that asks you to find the number of protons and neutrons within a particular element. So take sodium for an example. We know that the atomic number contains the number of protons in our element, and then the atomic mass contains protons and neutrons. So to find our neutrons in this scenario, we just subtract 11 from 22. That's going to give us 11. So it's 11 neutrons in sodium. Now let's do nitrogen. Nitrogen has an atomic number of 7 and atomic mass of 14. 7 minus 14 is going to give us 7. There's 7 neutrons within nitrogen. And you may even run across questions that ask you just plainly how many protons are in this element. And that's simply the atomic number once again. The atomic number contains the amount of protons within the element. So now we have aluminum. So we have 13 minus 26. That's going to give us 13 neutrons. Let's do one more. Magnesium. How to find the number of neutrons in magnesium. So we subtract the atomic number and atomic mass, and that's going to give us 12 neutrons for magnesium. So you will be asked to identify an element and classify it as metal, semi-metal, or a metal. So an easy way that you can remember this is to know that most of the elements on the left side of the periodic table are metals, excluding hydrogen, which is highlighted in pink. And then once you get familiar with the semi-metals, they are starting with bromine there. They kind of create like a little stairway. This is how I remember, y'all. Like it kind of creates like a stairway. So everything after bromine on the right side of the periodic table is a 9 metal. And of course the lanthanides and the actinides at the bottom of the periodic table, these are metals as well. You also need to be familiar with group names. Everything is color coordinated for you all. We have in blue, we have our other 9 metals, and then in orange we have an alkaline metal group, and then we have the alkaline earth metals, they are in light orange, and then in lime green or green we have the transitional metals. In yellow we have the post-transition metals, and we have the melatoids or semi-metals, the stairways that we talked about in the last slide. And then we have a group, the halogens. These are highlighted in purple. And then we have the noble gases in light blue. And then we have the lanthanides in green, and the dark green, these are the actinides. So take some time to look at this periodic table and try to remember the different periods and the group numbers. You see some numbers at the top of the periodic table. That's the group number. And then we have the periods on the side, 1 through 7. And so you just know the different periods and the different group numbers. Okay, so now we're going to be calculating the molecular weight. And we do this by writing out the elements in each chemical formula. And then we calculate it by how many elements are present in that particular formula. And we just add it up. Okay, so the question says, what is the molecular weight of ethanol? So we're going to take our carbon, and we're going to write out the atomic mass or the molecular weight of carbon. And as you see, it is 12.01. Because we have 2 carbons within this chemical formula, we're going to multiply 12 by 2. That's going to give us 24. Now, the number of hydrogens we have in this particular problem, or in ethanol, we have 6 hydrogens. So we just calculate 1 times 6. That's going to give us 6. And the atomic mass for hydrogen is 1.006. So we just not including that. The 6 is not necessary. Now, oxygen, we have 1 oxygen molecule in this particular chemical formula. So the atomic mass for oxygen is 15.99, but we're just going to go ahead and say 16. So we're going to take 24, 6, and 16, and we're going to add that together, and that'll give us the weight of 46. The molecular weight of ethanol is 46. Okay, so now we have another problem, and I just wanted to point out that the molecular mass is also called the molecular weight, and that's pretty much the atomic mass in a molecule. So the question asks, calculate the molecular weight of sulfur dioxide. So the first thing we're going to do is write out sulfur and write out its molecular weight, or its atomic weight. And so that is 32.06 for sulfur. And next we have oxygen. Now we have 2 molecules of oxygen, and oxygen atomic mass is 15.99. You can use that, or you can just round it up to 16. It depends on you. You should come up with the same answer, or just about around it. So we have 2 oxygen molecules, so we multiply that by 2. That is going to give us 32.00. And so we just add 32.06 plus 32.00. And that's going to give us 64.06 as the atomic mass for sulfur dioxide. There will be a few questions about scientific notation on the test. So the first question says 3 is 3.2, and we're going to turn it into scientific notation, and we do that by writing 3.2 times 10 to the 0 power, because it's 0 power because we don't move the decimal place anywhere. Okay? Scientific notation is a scientific system of writing very big or very small numbers easily. Now we have our next problem, 4.28 times 10 to the negative 5th power. Because it's a negative exponent, I know that I'm going to move from right to left, meaning that all of my zeros will be in the front of the problem. So we're going to break down this scientific notation problem. So that means 0. We got 5. So we're going to do 4 zeros, which is the 5th place. That's why the 5 is there. Is going to be our significant 428. Now the next question we have, we're going to turn that into scientific notation. So you may get questions that ask you to turn this into a scientific notation problem, or vice versa. So we do this by counting the number of places we have until we get to 6, and that's going to be 8 places. So we write that by like 6.02 times 10 to the 8th power. Okay, so you want to be familiar with the prefixes and how they expressed grammatically. I did see a few of these on the Hesi. I remember seeing nano, and deci, and centi. So just know how they expressed pneumatically. Ions versus isotopes. Ions are when an atom is electrically charged and is in an ionic state. It either loses or gains electrons. There are 2 different types, cation and anion. The cations are positively charged, they gain protons and they lose electrons. Whereas our anions, they are negatively charged, they lose protons and gain electrons. One way that you can remember is by thinking of cats. Cations, cats are positive, and the prefix an means without or lacking. So if you're without or lacking, it's a negative experience. So anion, negatively charged. Isotopes are atoms of the same elements, but they have different mass numbers. For an example, we see carbon. There's 2 different mass numbers. Now, one thing I also want to point out to you guys, is that if the mass numbers are switched, don't be confused by that. Just know that the atomic number will always be less than the atomic mass, because once again, the atomic number contains protons and the atomic mass contains protons and neutrons. Solid, liquid, and gas. So you will be asked a question to identify the different characteristics of solid, liquid, and gas. So let's start with liquid. Liquid has a definite volume but assumes the shape of its container. If you were to pour a glass of water into a bowl, it would form the shape of a bowl. If you were to pour the glass of water into an ice cube tray, the water would form the shape of the ice cubes. That's what we basically are talking about. It's high density, it is slightly compressible, and that basically means that the volume can change when there's pressure applied to it. The motion of the molecules slide past one another very freely, as you see on the picture. They're close together, but they're not as tight compared to solid, which we'll talk about solid now. Now, solid has a definite volume and shape. It's high density. It's incompressible. The motions of the molecules, they vibrate about fixed positions, so they're kind of like tight together, as you see in the picture. You have to think about when water is frozen. This is a picture of an ice cube, by the way, if you can't really tell. So when ice is frozen, the molecules are compacted together. They're close together. So that's a solid for you. And as far as our gas assumes the volume and shapes of its container. It has a low density. It's very compressible. Its motions of molecules, it's very free formed, as you see in the pictures. The molecules are all over. Now we're going to talk about temperature. Now you might want to get familiar with these formulas, and there are different formulas out there that'll give you the same result, but these are the ones I decided to go with. Okay, so know Fahrenheit to Celsius and vice versa, and also Celsius to Kelvin's formula. Okay, so let's do some conversions. Let's convert 68 Fahrenheit to Celsius. So basically, we just plug in the formula that I just circled, and we put our Fahrenheit as 68, and then that's going to give us 20 Celsius. Yeah. So next we have convert 40 Celsius to Fahrenheit, and I'm going to just change the color here. And we're just going to use the formula right here. Basically, we just plug in 9 Fahrenheit over 5 Celsius times our Celsius, which is 40, plus 32 Fahrenheit, which is going to give us 104 Fahrenheit. Now, next we have, after I finish writing this, of course, next we have convert 23 Celsius to Kelvin. Now we just use a formula here. Use the formula that I'm about to circle. So we just basically plug in that 23 in the place of Celsius to get our Kelvin. 23 Celsius plus 273.15 times 1 over 1 Kelvin over 1 Kelvin, 1 Celsius. That's going to give us 296.15 Kelvin. So you need to know the difference between a chemical change and a physical change. A chemical change is when an original substance has transferred into a new substance. Basically, the chemical change causes different priorities in the substance. Let's look at a piece of paper or a ribbon or something like that. So if you burn that piece of paper and it turns into ash, it has different priorities now. That's a chemical change. Now, a physical change is a transformation that do not produce new substances. So that same sheet of paper, if I were to cut it up into tiny little pieces, it doesn't even matter how many pieces, it could be 1,000 pieces, it is a physical change because I can glue those thousands of pieces of paper together. Okay, but when I burn it, I can't get it back. You see the difference between a chemical change and a physical change? There are 2 types of chemical bonds that you want to be familiar with for your exam: covalent bond and ionic bond. Covalent bond is the strongest type of any bond. These are formed when 2 atoms share electrons, and they generally are shared in pairs. If you look at the picture there, we have 4 yellow illustrated electrons. These are sharing pairs, as you see. Now, ionic bond is an electrostatic attraction between 2 opposite charges. Ions, whether that's a positive charge or a negative charge. Generally, these are formed between a nonmetal and a metal. And if you look at our illustration, we have sodium and chlorine. And sodium is a metal, alkaline metal, and chlorine is a non-metal. So this is an example of an ionic bond. Now we're going to talk about the different radiation waves. Up first we have is alpha radiation. This is the largest of the radioactive waves, and they can be stopped by a sheet of paper. Now beta radiation, the particles are neither positively or negatively charged. They can be stopped by a sheet of aluminum foil. Now, gamma rays are similar to X-rays. They can penetrate through several feet of concrete and lead. So you want to be familiar with the pH scale. You will be asked to identify certain elements, pH scales levels. For an example, lemon juice. They may ask you what is the pH level of lemon juice. So it's 2. And as nurses or any healthcare workers, you need to know the pH level of blood. It doesn't go away. It just doesn't. So that is 7.35 to 7.45. That is the pH level of blood. Okay. So familiarize yourself with this scale here, and know that if something is acidic, it donates hydrogen, and if it's basic or alkali or alkaline, it is hydrogen receptors, meaning that it loses hydrogen. So the more basic, it's losing hydrogen, and the more acidic, it has hydrogen. Hence the name pH. The P stands for potential and H stands for hydrogen. So when you think of the pH scale, think about hydrogen. More acidic, you're gaining hydrogen, and more basic or alkaline, you're losing hydrogen. The 5 basic types of chemical reactions. First, we have synthesis or synthesis. This is when 2 elements combine to form a product. For an example, we have A and B, and that's going to give us a combination of AB. The same thing with carbon and oxygen. Next, we have decomposition. This is the breaking down of compounds into component parts. So basically, it is the opposite of synthesis. Instead of combining, it actually breaks down the elements. So one example, we have AB together, and then it breaks off into A and B separately. Next, we have combustion. Now, combustion, I want you to always think about fire when you hear combustion, because essentially it is the burning of gases. This is when a chemical reaction where oxygen and fuel react with each other, and it will always contain CO2 and H2O as a product. Okay, and as you see, we have some examples on our product side. We see CO2 and we see H2O. That is how you can identify a combustion reaction. Next, we have single placement. Single placement reactions consist of more than one active metal reacting with an ionic compound. Once the element starts out by itself, it ends up kicking the other element out. So looking at the example, we have copper with silver and nitrogen and oxygen, and then on the product side we see that copper is partnered with nitrate, and we see that silver is alone. So this is an example of a single replacement. Now, double replacement, these are when reactions involve 2 or more ionic compounds. The positive and negative ion compounds, they switch places. So unlike single replacement, everybody has a dancing partner in this case. Now we have our silver nitrate with potassium chloride. We see that they are together on the reactant side, but then on the product side we see that we have silver and chloride, or silver chloride. They're paired together, as well as potassium nitrate. So potassium and nitrate paired together. So they just basically switch dancing partners. Intermolecular forces. Intermolecular forces are attractive forces between molecules. They hold atoms together in a molecule. Hence the name inter. Inter means in between. Now we have hydrogen bind, dipoid, and dispersion. There are many other intermolecular forces, but on the Hesi, these are your main focus. These should be your main focus. So hydrogen bind intermolecular force is an attraction of a hydrogen atom by a high electronegativity element. It usually involves fluoride, oxygen, and nitrogen. We have some examples here. We have H2O. We see the oxygen is there. And then also want to point out, these hydrogen bonds are the strongest bond of them all. So you need to know that for sure. Now, dipoid is the attraction of dipoid, one molecule of a dipoid of another molecule. And this happens when the electrons are shared unequally. Now, dispersion, these are when electrons concentrate themselves on one side of an atom and causes a momentary temporary dipoid. Okay, so now we're going to get into a little bit of biochemistry. So we have carbohydrates, proteins, nucleic acids, lipids, those 4 main macromolecules. Be familiar with what their functions are and also associated names. Oxidation and reduction. The main thing you need to know is that oxidation reduction is also called redox, which is a transfer of electrons. Oxidation is the loss of electrons, and reduction is the gain of electrons. There's a mnemonic that we use in chemistry, old rig, and it basically means that the O stands for oxidation is loss, it loses electrons, and RIG, that means reduction is gain. That means reduction is the gaining of electrons. So the oxidation number of any number or any element is 0. Now this is a test question. I do remember seeing this on the Hesi. Now the exceptions are as follows. Okay, so just take some time to look over that information. Conversions. On the test, you will be given density, mass, and volume problems, so just be familiar with the formula and you should be fine. So the first question says, a lead ball has a mass of 400 grams. The density of a lead is 10.5 grams / cubic centimeters. What is the volume of the ball? So to find the volume here, we would have to divide our mass. So I'm just writing out our mass is 400 grams once again, and density is 10.5 grams / cubic centimeters. So we just divide those two, and it's going to give us 38.09 cubic centimeters at the volume. The next problem says a loaf of bread has a mass of 500 grams and a volume of 2,500 cubic centimeters. What is the density of bread? So we're given our mass, 500 grams, and our volume, 2,500 cubic centimeters. So to find our density, we just divide our mass and our volume. And that is going to give us a total of 0.2. So be familiar with Avogadro's number is 6.02 times 10 to the 23rd power. Balancing equations. One thing you want to keep in mind when we're balancing equations, what we do to the reactant side, we must do to the product side. Now, first thing you want to do is write out what you have on each side. On our reactant side, we have 8 sulfurs and 2 oxygens. Product side, we have 1 sulfur and 2 oxygens. So we can see that this is the unbalanced equation and that we must do something to balance this equation out. Well, since we have sulfur on the reactant side, we're going to go ahead and add 8 to balance this equation. 8 in front of the oxygens, 8 in front of the sulfur and oxygen on the product side. So we multiply 8, and that is going to give us a balanced equation. You see what I did? I hope you see what I did. Okay, so now we're going to rewrite this problem so that it can look more balanced. All right, so now we have 8 sulfurs on the product side and 8 sulfur on the reactant side. See how everything balances out? So let's try that again. On our reactant side, we have 1 aluminum and 2 oxygens. And on our product, we have 2 aluminum and 3 oxygens. So we can say this is unbalanced, just like the other problem we had. So we want to add a 3, rather multiply a 3 where it's needed, so that we can end up with a balanced equation. And I hope you guys are following along well. If not, try to watch the older chemistry video. I feel like I broke down things a little bit better. It's kind of complicated to do that. But anyway, this is a balanced equation now. I'm going to rewrite that. And as you see, when I rewrite that, everything is balanced on reactant side as well as the product side. All right, you all, that is pretty much it. Thank you so much for watching this video. Be sure to like this video, comment down below, and make sure you share this video. Subscribe to the channel and also check out the merch, you all. It's some pretty cool stuff there. And good luck on your exam, and I will see you on the next one. Bye.